In today's lesson, we are going to be introduced to the game controller. First of all, in case that you don't have the code of the project of the last lesson, you can download it from this link. And starting the lesson, what is the game controller? The game controller will be the class that will keep the general state of the entirety of the game and all its elements. Okay, so let's go directly to the code. And we will start creating the script called GameController. Okay, and we will create it into a new folder. In the folder game, scripts, controllers. So we can create the folder just right here in the scripts. We create a new folder, controllers. And inside this folder, we can create a new script called GameController. Okay, now on the hierarchy, we can create an empty game object that we will call also GameController, and we will attach our GameController script to that new game object. Okay, so this game object will be responsible to keep track of the state of the game and also its elements. But before going into the code of the game controller, we are going to try to abstract some functionality so we can use it also for our game controller. Okay, what I mean when I talk about abstracting functionality is taking functionality from existing classes and putting it in a higher class, so other members that inherit from this higher class can benefit from that behavior. That's what we did in the case of the player, the enemy, and the NPC. That when we were implementing all these classes, there were methods that we were able to move it to the avatar class in order for all the classes that inherited from avatar could take advantage of. Okay, if you recall, for the case of the player, we had a method called move to position that we were able to move it from the class player to the class avatar in order for the enemy and the NPC to be able also to use that particular method. Okay, so right now I am proposing you an exercise about what kind of functionality could share both the avatar and the game controller. Okay, there is at least one shared property and functionality that both elements have in common. Okay, so please give it a thought and come back when you have something. Okay, so the shared functionality that both game controller and avatar are going to have is the is the finite state machine behavior. Okay, because game controller is also going to work into a finite state machine. Okay, so what we are going to do is that we are going to create a new class called the state machine that both game controller and the avatar are going to inherit from, in order for both be able to use all the functionality that allows the finite state machine. Okay, so what we are going to do right now is we are going to create the script state machine into a new folder. Okay, this new folder being in-game scripts IE, because we are going to consider the state machine as artificial intelligence component. Okay, so going back to the code, we are going to create a new folder in scripts called IE, and inside this folder we are going to create the script state machine. Okay, and now I propose you to do the exercise to implement what's going to be here in this state machine. You have to consider that we are just moving behavior from avatar to the state machine. So we are going to move basically two things: the private protected member variable, the state, and the protected member method, change the state. So please go ahead and do it. Okay, and the final result should look something similar to this. What we have just did has been just to take what we need to implement the finite state machine behavior, that was the private member variable state and the method, and just move it from avatar to state machine. Okay, and the next thing that we are going to do is, okay, avatar still needs the behavior of a state machine, and so he's going to inherit from state machine, and he's going to take advantage of this behavior. Okay, now we can go to the game controller and we can just inherit also from state machine. So right now game controller has also what is necessary to implement a finite state machine. So what we are going to do now is to use our knowledge of finite state machines to create a diagram of the states for our game controller. Okay, try to think about the typical general states that the game can be. Okay, and also think about what conditions must happen in order to change between the different states. Okay, so right now you have to go back to the diagram editor. Okay, and here you are going to create the state machine for your game controller. Okay, you will create different states, and in the different states you will represent the most typical states that the game can be. Okay, so go ahead and implement it. Okay, and the result should look similar to this one. We are just using the most basic states that a really simple game can have, and we will have just the main menu state where it will be displayed the main options of just to play the game. And after that state, if we press the play button, we will go to the loading state. In the loading state, the game will load any necessary resources to run properly the game. When the game resources have been loaded, the game can start. So we will transition to the state run game. And from the state run game, we can transition to two different states. The first state would be the state win. That happens when all the enemies have been killed. And the other state that we can transition from a run game would be the state lose. that happens when the player dies. Once we are in both win or lose states, we will have a button in the screen to allow the player to go back to the main menu to repeat the game again. Okay, this is the most basic game controller finite state definition, and we are going to work with this one. The next step in the process of converting the finite state machine into code would be to create the table, the design table to represent the finite state machine. Okay, you can download the table from here and open the table with, and here you can start translating from the finite state machine diagram to the table state machine diagram. So go ahead and do it. Okay, and the table definition of the finite state machine diagram should look similar to this one. Okay, we have first filled both the rows and the columns with the states of our finite state machine, and we are started by just defining the transitions from main menu to loading with the press of the play button, from loading to run game with when the game has fully loaded all the resources, from run game to win when all the enemies have been killed, and from run game to lose when the player dies. Finally, for the win and the lose state, when the user press the button to go to the main menu, they will transition to the main menu. In the states, in the same states, in the main menu state, we are going to show the main menu, okay? In the loading state, we are going to load the game resources. And in the run game, the most important is that we are going to run all the game elements. In the win state, we are going to show the win state, and on the lose state, we are going to show the lose state, okay? So the table should look similar to this one. For the next step, we are going to do the pseudocode. Okay, so open your favorite notepad and translate your table. Okay, and the pseudocode could look similar to this. You have to remember that the pseudocode is something personal for each individual. There won't be two pseudocodes that would be equal. The pseudocode is the personal way you have to express the design table. Okay, so what we have done is, okay, we are evaluating the state. In the case that the state is the main menu, as an action in the same state, we are rendering the main menu. And conditions to transition to different states, we have that if the user has pressed the play button, okay, we transition to the load game state. Okay, we do that. In the state of load game, as an action, okay, we are loading the game. Okay, here we will do the action to load the game, and as a condition, if the game has completed of loading all the necessary resources, it will transition to the state of the game running. Okay, so in the state of the game running, as an action, it will run all the game elements, and it has two conditions to transition to win and lose. If the player has killed all the enemies, okay, then it should transition to the win state. Okay, and if the player is dead, okay, then it should transition to the lose state. Okay, finally, for the state win, we show first as an action, we show the win screen, and as a condition, we check if the user has pressed the next button to go back to the main menu state. In the case of lose, we do exactly the same. We show the lose screen, and when the user presses the button, then he goes back to the main menu state. Okay, so now the next step would be to translate all of this to code. So now we can go to the code. Okay, and we can start to translate the code, the pseudocode that we have just done. Okay, and but first we will start declaring the public constants of the states that we have detected. Okay, so we are going to these constants, we are going to declare them in the GameController script. These constants, the load menu, the game running, the win state, and the lose state. Okay, and each constant has a different value. Okay, next we are going to implement the switch on the update method. Okay, and for the moment we are going to the functions that we have identified in the pseudocode. Okay, we are going to leave them empty. We are going to declare the methods and functions, but they are going to be empty. We are going to focus right now just to create the skeleton, the structure. Okay, so we'll go to the code, and right here we are going to do the switch. We are inheriting the M state from the state machine. Okay, as you can see, it's inheriting from a state machine, and we are evaluating the whole thing. Okay, so we can translate all of this to here. So the closer your pseudocode is to the real code, the easier would be to do this step. Okay, so when you get used to think about code, this process would be more straightforward. And now we are going to implement the methods, just leaving them empty. Okay. Okay, and that's the implementation of the skeleton of our finite state machine. Okay, right now all the methods that are being used in the final state machine are empty, because what we are going to do next is to implement all these empty methods. But for the moment, you shouldn't get any compilation error if you go back to the code, to the Unity project, and you shouldn't get any compiling error. Okay, so we are good. As a final test, just to ensure that we didn't break anything in the project, on the start method, we are going to change the state of the game to the state of game running. Okay, so go to the start method on the game controller, change the state to game running. Okay, I have here a spelling mistake. I can correct it with rename, so game running. Okay, and now if you go back to the Unity project and press play, you should get the previous behavior. Okay, the behavior of that we implemented in the last lesson. The enemy gets close, and if it's in shooting distance, it will shoot, and if we get away from it, he will go to initial random position. Okay, so that behavior is still intact. Okay, so we are good. So the next thing what we are going to do, I need to keep stressing the importance of the change state method. Okay, because it's the method that we will be able to use to detect the exact moment when there is a change on the state. Okay, so what we are going to do is something very simple. We are going to extend it, and we are going just to display a log message. Okay, when for each case. Okay, as you can see here, you can copy paste the whole code, so we can copy paste. Let's put the change state just above the update method. Okay, and what we are doing here is just in the exact moment that we are changing the state, we are just displaying a log message that will tell us that the state has been changed. Okay, so we are going to start implementing our finite state machine, and the first state that we are going to implement would be the main menu state. Okay, first of all, on the start method of the game controller, instead of changing the state to game running, we are going to change the state to the main menu. Okay, so do this change, go to the codes, and in the start method we are changing instead of the game running to the main menu. Next, we are going to create a public variable member that will reference the screen that we are going to use to display the main menu. Okay, so it's a public game object, and we will call it screen menu main. Okay, and now we can go back to the Unity editor, and we are going to create inside the UI a new canvas, and this canvas we are going to rename it to main menu. We can also rename this canvas also to game HUD, just to differentiate both of them. Okay, and in this new canvas, we are going to add a button. So go to the UI and create a button component. Okay, this new button we will rename it to play game. Okay, We are going to the 2D representation, so we are able to modify the button in any way we want. Okay, so we are going just to make it a little bit bigger, and we are going to change the text inside just to play game. Okay, so the final step that we are going to do is, for our game controller, we have the previous reference that we have declared, and we are going to set the reference to the canvas we have just created. Okay, so next we are going back to the code, and we are going to implement a new method that we will use in order for to detect when the button has been pressed. Okay, so first please copy paste this method, and you can just place it just after the start method. And what this method is going to do is going to listen when the button has been pressed, just to put a boolean variable to true, and this boolean variable will tell us, okay, the user has pressed the button, then we can transition to the next state. Okay, this boolean variable is not yet declared, so proceed to declare this boolean. Okay, private boolean, and initialize as false. Okay, and what we are going to do is, back to the Unity editor, if you select the button, okay, you in this section right here, okay, let me collapse this. In this section right here, you can see on click, and we can press in this add button, we can add a new entry, and this will allow us to call a method when the button has been pressed. Okay, so the method we have implemented is on the game controller. Okay, is play clicked. Okay, so in order to call that specific method, what we need to do is to specify here the game object with the script that contains the method we want to call. Okay, in this case it's just game controller, and here in this section we are going to select the method we are going to call when we are pressing this button. So click here, go to the game controller, and here you will find the method we have just declared. Select it, and when the user presses this button, this event happens. It will call in the game controller the function play clicked. Okay, the next thing we are going to do is back to the code. We are going to use the boolean that we are setting to true when the button is clicked, and we are going to use it in the moment that in this function, in the user press play button. Inside this method, this function, if we go to the declaration with pressing key F12, instead of returning false, we are going to return the boolean variable that we set to true when the method has been performed. Okay, so we are going to return it here, and the flow that we are going to get is that, okay, we are entering this state, and we are checking if the user has pressed the play button just by checking the boolean variable that will be set on play clicked. Okay, so what we can do is play it right now and check the debug log message in order to verify that the flow is the right one. So we press play. Okay, and right now we are getting that the game controller is in the state main menu. Okay, let's clear the log, and if we press the button play, okay, we get the message that the game controller is on the state load game. That would be the message that we are getting right here. So right now we are just displaying a debug log message right here, but we are interested to do more when we are changing of a state. Okay, so if you recall the past lesson, we saw that there are options when we are transitioning of a state to perform some actions. Okay, so in the moment that we are transitioning of a state, we can perform some actions. Okay, so can you think about an action to be performed in the moment that you transition from main menu to load menu that can help us out to better identify that we have transition from this first main menu state to this second state? Can you think about some action? Just give it a try and come back with a solution. Okay, and one possible solution would be that, well, when we are transitioning to load state, we are interested just to disable the main menu screen, just to deactivate or destroy it. So let's going to do that. Let's going to disable the main menu when we are transitioning from the main menu to the load game state. Okay, so what we are going to do is we are going to create a new method, activation screen menu main, that will have one boolean parameter, and that method will activate or deactivate the main menu canvas. Okay, and we will call this method, we will call it once, just in the exact moment that we are transitioning from main menu to load menu. Okay, as I told you before, we have the right spot, the perfect spot to transition from one place to another, to execute one-time actions. Okay, so please go ahead and implement this method. Okay, and the solution should look similar to this. In the method change state, that it's the right spot to detect when we are transitioning from one state to another. In this one-time operation, we are going to just disable, call the method activation screen menu with the false as a parameter, in order to disable the menu canvas screen. Okay, so we can go to the Unity project and test it. So let's play, and when we press the play button, it will disappear. If you can notice, the main menu has been deactivated. Okay, so let's keep doing progress for our game controller. And the next step that we are going to do, we are going to create a canvas, and we will rename it to screen load game, with only a text message that will display just the message of loading. Okay, we will create a public variable member just in the same way we did with the screen menu canvas in the game controller, just to make reference to that previous canvas. And we are going to create a method, activation load screen, that will allow us to activate and deactivate the screen. As we did before, we will create with that method with one parameter, and this parameter will allow us to activate or deactivate that particular screen. Okay, and finally call the function only when the state has changed to load game. Okay, so go ahead and implement the solution. And the solution should look similar to this. We have created the new public member variable screen load game. I have missed to link it to the screen in the UI, so we are going to create right now the canvas, okay, of with the new screen. So load screen, and inside this new canvas we are going to create a new text message, okay, and we will, in this text message, we will use the text loading. Okay, let's disable both main menu and GameHub, so in order to be able to see what's going on with our screen. Okay, so we have here the text field. We are going to center the whole thing, and we are going to make it a little bit bigger so we can see it better. Okay, so here you can see the loading text. Okay, and this loading text, what we are going to do is just drag the canvas and set the reference to the public member variable we have just declared. Okay, the next step was to create the method that will allow us to activate or deactivate the screen. Okay, so we create the method, the parameter, and we use the method set activate of the game object to activate or deactivate the method. Finally, we are going to use it. And where we are going to use it? Well, when we are transitioning to the state load game. We are interested in the state load game to disable the menu main, but we are interested to enable the load game screen. Okay. Also, a method that is going to be pretty useful right now is we are going to create a method that will disable all the screens. So disable all screens, and well, this method will do what it says the name of it. It will disable all the screens. Okay, so we are going to place it right here, and what will happen here is just deactivating all the screens. And the new screens that are going to appear, we will have to add it right here. And what we are going to do with this method is use it just to initialize the whole system. When we are calling to the main menu, we disable all the screens, and we enable just the one we want to enable, that is in this case the screen menu main. So just after this line we enable the main menu screen. Okay, so now if we go back to our code, we can either activate all three elements, or even deactivate all three elements, because since they are referenced by the game controller, we will be able to activate and deactivate in the same game controller. So let's start with all of them deactivated. Let's switch back to 3D and let's focus on the player. Okay, so let's go to play the whole scene, and we are starting with only the main menu activated. We have disabled in this case the load screen and the main menu, and we have activated the main menu. And the next thing that will happen when we press play, the loading screen would be activated. Okay, so everything is in order and the flow is being performed in the right way. So now that we have reached the state load game, we are going to do some things in this state. What we are going to do is we are going to fake what would happen in a load game state of a game. In a normal load game state of a game, the graphic resources, the sound resources, any kind of resources that might need the game are going to be loaded, and a progress bar should be displayed in the screen. We are going to keep it simple right now, and the only thing that we are going to do is just to stay in this load game state for some seconds, and after that that period of time has been finished, then we will transition to the next state that will be the game running state. Okay, so right now what you should do is that you have to implement a way so after several seconds there is a transition from load game state to game running state. Okay, so remember that Unity has a way to get some time values that we have already seen. So please use that utilities in order to get the desired behavior. The desired behavior, I repeat, it's after some seconds there should be a transition from load game state to game running state. So go ahead and do it. Okay, and the code should look similar to this. What we have done here is first of all we are doing the time tracking progress of the time we are going to wait until transition to the next state in the method load game. In order to do that, we are using the time utility, Unity time utility, in order to just to increase a value, and when this value is above 4 seconds, we are going to set this private member variable, okay, to true. And this private member variable is being used by this function has loaded game. That is the condition that it should be triggered in the state load game in order for the state to transition to the next state, to the state of game running. Okay, the last thing we need to do is just to disable the load screen right here. So what should happen when we go back to the Unity editor and we run the whole thing is that first of all we will see our main menu screen. Okay, that's correct. If we press the play button for 4 seconds, the loading screen should appear, and as you can see in the debug log message, there has been the transition from the previous state load game to the new state to game running. Okay, so by this way we have fake just a loading time, a loading progress, in order to just to understand the concept. So right now you may have noticed that even if we are on the main menu state, the game logic of all the elements, the enemies, the NPCs, everything is running. Okay, and we are not interested that all these elements run when the game controller is in the main menu state. Okay, so the steps that we are going to do in order to for the game elements only to run on the game running state would be this. We are going to introduce a new state for all the avatars. Okay, that would be called state initial. In this state, nothing will happen. No logic will be run in any case. Okay, and enemy, player enemy, and NPC, all three elements are going to call to change to this initial state just in the start method. So now let's go back to the code, and we are going to add new states for the three elements: the player, the enemy, and the NPC. So go ahead and do it. Okay, and the code should look like this. We have created for the three elements: the player, the enemy, and the NPC. We have created a new state, the state called initial, and in the three elements for in the update method, we in the case of initial, we are not running any kind of logic, so nothing should happen when all of these three elements are in their initial states. Okay, nothing will happen. So now let's test it, and we are going to go to the Unity editor. We are going to press play, and since no logic is being run in the game player, you will notice that you cannot move at all. You cannot move the camera, you cannot move with the arrow keys, you cannot do anything, because the player is in the initial state, and also the enemies are on the initial state. Okay, so the next step now is reactivate all the game elements so the game can perform as we expected. So what we are going to do is that we need to reference the player, the enemies, and the NPCs, so we can change their state back to the normal state, to idle, so they can perform their own finite state machines, their own behaviors, so that the game can happen. Okay, so the first that we are going to do is that in the GameController we are going to reference all the game elements that we have changed the state to the state initial. That is the player, the enemies, and the NPC. We are going to create three public member variables that we are going to use to reference all the elements that are in the scene. So let's go back to the code. Okay, and we are going to use these public variable members just right here. For example, since they have pretty good priority, we can place it just above the screens. And now if we go back to the Unity project and we select the game controller, you can see here that my player has appeared, the enemies array has appeared, and then PC array has appeared. Okay, so my player, we are going to reference my player with the player that we have on our game scene. Okay, And for the enemies, we have 3 enemies. Okay, so let's put here 3 enemies, and let's reference each one of them. Okay, 1, 2, 3 enemies right here, and also 3 NPCs right here. So let's go into reference them also. One NPC here, the other here, and the final one here. Okay, so we have the reference right here, and we can use that reference to reactivate them, to change them from initial state to an state where they will be performing their logic. So in order to reactivate all the game elements when the game controller transitions into the game running state, we are going to introduce to a new programming concept that are the abstract methods and also the abstract classes. Let's check the definition of abstract methods and classes. A method that is declared abstract has no body, okay, and is declared inside the abstract class only. An abstract method must be implemented in all non-abstract classes using the override keyword. Okay, what this means for our particular case. Okay, so we are interested to implement this abstract method, okay, init logic. And what this method would do would enforce that all, first of all, this method has no body, as you can see, there has no content. And what this method does, it forces to all the classes which inherit from avatar to implement that method. As you can see right now, we are having a compiling error. Right now the compiler is telling us that player does not implement the inherit abstract member init logic, and this will happen in all the bullet is also included in all 4 cases, enemy, and finally also the bullet. So in all the cases that classes that who inherit from avatar, they need to override this method to implement it. We can use control dot to implement the abstract class. Okay, so the abstract, well, when you use the control dot, usually it places the code right to the end of the file, but since this is something related to initialization, it would be nice if you place it just close to the start method. Okay, so what we are doing here is we are overriding the method, the abstract method init logic. Okay, and what we are doing, what we are going to do inside here is, okay, we were on the initial state, and we are interested to activate the logic, the finite state machine of the player. To activate the final state machine of the player, we only have to change to the state of idle. Once on the state of idle, we are inside the finite state machine, and the logic of the player will start. And we are going to do the same for the rest. For the enemy, control dot implement the method. We are going to also move it close to the start method, and in this case from initial it will go to check for player. Okay, so we are overriding the abstract class, and inside the init logic we are changing the state to change from initial state to check for player. Okay, now we have to do the same for the NPC. Control dot autocomplete, get the method, move it close to the start, and also here we are going to change the state so the NPC also starts with its own behavior. Okay, finally for the bullet, even though the bullet inherits from avatar, he's not using any kind of states, so you can leave it just empty the body of the method. But still it needs to override, because when you are declaring an abstract method, you are forcing to all classes who inherit from avatar to implement this method. Okay, and the another change that we have had to make is that we have had to convert the avatar class to an abstract class, because you cannot use abstract functions in a class that is not abstract. What means to convert a class to abstract? If we go to the definition, an abstract class is never intended to be instantiated directly. What does this mean? This means that you cannot have an instance of only avatar. Before that, it was possible to have an instance of only avatar. If you went to the code, let's convert it first of all to virtual, so we can have an instance of avatar, and it was possible to create just an empty object right here, and let's call it avatar, and we can add here the component avatar. That won't be possible if we convert the avatar into an abstract class. An abstract class is meant to be used as a base, a definition, but never an instance. Okay, so by converting it to an abstract class, okay, let's undo the changes. Converting it to an abstract class, we are never going to have an instance of avatar, but we don't need to, because what the instance of what we need are from player, NPC, enemy, bullet, or any other class who inherits from avatar. In avatar, what we can do is just to place shared properties, shared behaviors. As you can see, it's possible just to declare function with a body. So we are still taking advantage of the whole hierarchy of the object-oriented programming methodology. And we can also use the abstract methods to enforce that all the derivated classes implement the method. Okay, so now that we have implemented our init logic method in all the derivated classes from avatar, we can now proceed to call this method from our game controller in order to just to initialize the logic, start the logic of all the game elements. So the exercise that you are going to do would be the next. You are going to implement a new method that will be called initialize logic game elements, and this method should call the init logic of the player, the init logic of all the enemies, and the init logic of all the NPCs. Okay? In case that you have some doubts about how to go through all the elements of an array, just search for any example in order to get a clue of how to do it. So go ahead and do it. And the code should look similar to this. Okay, so we have started by implementing the method initialize logic game elements. The goal of this method is to initialize all the game elements so they can start running its own logic. We started with the player, calling its init logic method, and then going through all the elements of the array, initializing the init logic of all the elements for the enemies, and we are doing exactly the same for all the NPCs. Finally, we are calling this method when we are transitioning to the game running state. Okay, we are running it only once, and then the game will start. Okay, so now if we go back to the Unity editor and press play, in the main menu screen we cannot move the camera also, and we press play button, and for 4 seconds we still cannot move, but when we finish the 4 seconds we are able to move. So the logic of the elements is running. Okay, also the enemies and the NPCs are running. This one is shooting at me right now, that's good. Okay, the enemies are working, the NPCs also are working. This NPC is talking to me. Okay, are you talking to me? Okay, so he goes back to its initial random position. So we have our very basic game controller finite state machine up and running. To complete this first part of the lesson, we still need to implement both states win and lose, and that's what you are going to do. You are going to create a canvas for win and lose states, the same way we did with the previous screens. Just create a public member variable to reference each one of the screens you create for win and lose, so you can reference them from the game controller and just activate or deactivate depending the needs. Okay, and well, be free to customize them any way you want. So go ahead and do it. And if everything works fine, the conditions of victory and lose should be triggered. Let's start with the condition of victory. Let's kill all the enemies. Okay, we have 3 enemies. Let's kill all of them. Okay, and the screen of victory is being displayed properly. If we have implemented properly the button to go to the main menu, we should go back to the main menu. Okay, we have a mistake. Let's fix it. So the error that we have done is that we have a collection of multiple variables that we are using to check the different conditions that we are not resetting after they trigger their respective conditions. For example, user press play button on this boolean variable. Once it's clicked, the value remains as true. So the next time we change from win or lose to main menu, when we go again through this function, we are going to get also true, even though we are starting over. So what we need to do is just to reset all the variables that we have used. So when we need to start over, we start fresh. So we are going to get all these variables, and we are going to create a new private method, reset GameController state, and we are going to set all these variables to their initial state, so we can start over. Okay, and we can call this method. We can call this method just in the change state, when we are changing to the state main menu, just resetting the whole thing so we can start over fresh. Now if we proceed to test it, press play, go into the game running state, kill all the enemies, when we press go to main menu, we are staying in the main menu, even though we are still moving. Okay, in order to stop moving, to stop all the logic from moving, what we can do is just to create another method that would be stop logic, that will stop the logic of all the elements in all the classes who inherit from avatar. So we will go to all the classes who inherit from avatar, implementing the stop logic method by just changing the state to the state initial, that we already know that in the state initial nothing happens. Okay, so we can do that also for the NPC and for the enemy. And in the case of the bullets, we don't have states, but yet we have to implement the method. So we are going to just leave it empty and just below the init logic method. And now the only thing left to do is in the game controller to call that. And we are going to use as a template the same methods, initialize logic game elements to stop logic game elements. Okay, so here we will call stop logic, and stop logic. Okay, also since either the enemies and the NPCs can be destroyed, we have to consider to check the case that if they are different of null, because if they are null, they have been destroyed, and we cannot proceed to call the stop logic method because they don't exist anymore. Okay, so you have to check in this particular case, you have to check that the enemy or the NPC still exist. Okay, if it still exists, then you can proceed to stop their logic. Okay, so now if we go back to the only thing left to do is just to stop the logic of all the elements, and for example we can do that when we transition to the win state or lose state. We can stop the logic of all the game elements. Okay, so now yes, we can go back to the Unity project, press play, and when we transition from the game running state to the win or lose state, okay, let's go with the lose state. Let's get it. Okay, I have been killed, the player has been killed. So now if I press go to the main menu, I still can move because we have used the stop game logic elements, and we are now in the initial state. Okay, so now we are starting over, pressing play, going to the game, and you can notice that we are going back to the lose state. That's because we haven't resetted the player's life. It's another action that we should do. So we are going to reset the player's life by just implementing just here a method to reset the player's life. For example, public void reset player's life, and this method will just reset the player's life to the initial life. Okay, and this method would be called in the moment that we lose. So in this particular moment we can call reset player's life. This way, the next time we go back to the main menu, the player's life would be above 0, and we will be able to resume the game. Okay, so let's play it. Okay, loading game state, game running state. Let's get killed. Let's kill at least one enemy, and let's get killed by the other. Okay, and we are dead. We cannot move. That's correct. We go to the main menu state. We cannot move. That's correct. We press play, go to the game loading state, and now we are back to the game running state with the life initialized to the initial value, and if we get shot, the life gets decreased. And let's at least kill the enemy and trigger the condition that we have won the game. Okay, so we have won the game. Okay, so we have done our most very basic game controller based on the finite state machine we have designed. In the final step of this lesson, we are going to introduce a new state into our finite state machine for the game controller, and the new state will be the pause state. Okay, and what we are going to do is just to introduce the pause state directly. We are not going to add the new state in the finite state machine diagram, nor in the table. We are just going to introduce directly the state pause into the code. Okay, so we will start going back to the Unity editor, and we are going to create a new canvas for the pause. Okay, so go to UI, create a new canvas, rename it pause screen, and we are going to create two buttons. One button that would be to resume, and another button that would be to reload. Now back to the code, we are going to reference the pause screen. So let's create a new public member variable screen pause, and we are going to initialize it with the canvas we have just created. So select game controller and set the new screen pause. Next in the code, in the method to hide all the screens, we are going also to add the new screen pause. Okay. And next, what we are going to do is just to create the skeleton of the option of the state pause. So go ahead and implement the state pause. So just as a short summary of what you need to do, you are going to create a new state in the game controller called pause. You are going to evaluate this state on the update method. You are going to also to evaluate this state on the change state. And in the state game running, you are going to create a new condition that will allow you to transition to the state pause. Okay, this transition would be pressing a key, the key you decide, in order to go to the pause state. And in the pause state, there will be two conditions. One condition to go to the game running state, and another condition to reload the whole scene. Okay, so go ahead and implement the state pause as described right here. So the solution should look similar to this. First of all, we have created the constant for the new state pos, okay, and we have created the skeleton structure pos for the update and pos for the change state, okay. After that, we have created on the state game running a new condition that will help us to transition from the game running state to the pause state by just pressing the key P, okay. Inside the pause state, we have created two conditions. One condition that checks if the user has pressed the button to return to the game. Another condition that checks if the user has pressed the button to reload the game. In the case of returning to the game, we just change the state back to game running. But in the case of reloading the game, we use the utility of the scene manager and the method load the scene to reload the whole game scene to start over, okay. After that, we have created just the two methods, user has pressed return a game and user has pressed reload game, that it will be called in the buttons resume as the user has pressed the return game, and the button reload will call to user has pressed reload game, okay. These two methods will set these respective boolean variables, pressed to reload game and pressed to return game, and these two variables would be the ones that we are checking in the conditions to transition from the pause state to either the game running state or just reloading the game. Finally, we have created an activation method, activation screen pause game, okay, where we are just activating our screen pause game, okay. And the final change that we have done is in the game running state. If we are coming back from the state pause, we are deactivating the pause screen. And if it's not the case, if we are coming from the load game screen, we are just initializing the game elements, okay. So now we can proceed to run the game, okay. And we are going to test the pause behavior, okay. We press play, we are on the loading state, and now we are on the game running state, okay. So we are here, and now if I press the key P, the game has changed of state from game running to the pause state. We are still having the logic of the player, so we are going to fix that in the next step. But just right now, we are going to press the button resume just to going back to the game running state, okay. We go back to the game running state, and if we press P, we also have forgotten to reset the pause state. So we are going to fix both things. First of all, let's start by resetting the variables that we use in the pause state, okay. So for these two variables, we are going to create a method that will reset them once we need to them to be resetted. So we are going to create a method just right here, private void reset pause variables, okay, and we are going to reset both variables right here, false and false, and we are going to call the reset pause variables method when we leave the pause state, okay. So when we leave the pause state and we are going to the game running state, then we proceed to reset the pause variable so we can start fresh and be able to perform the logic of the pause state without any problems. In relationship to stopping the logic of the game elements, that is the player, the enemies, and the NPC, what we are going to do is I want you to think about where you can stop the logic of the game elements and resume the logic of the game elements. So go ahead and think about a solution. And the solution should look similar to this one. First of all, we already had our method stop logic game elements. That what this method did was to stop all the logic of the player, the enemies, and the NPC just by changing their state to this initial state. Okay. And the next thing that we are doing is when we go back from the pause state to the running state and the previous state is pause, we aside from resetting the pause variables, deactivating the pause screen, and we are again initializing the logic of the game elements. So we should be good to go right now. So let's go back to the Unity project. Let's press play. Okay, let's go to the game running state. Okay, and let's move things around. Okay, let's trigger some behaviors. Okay, so the things are moving. I am going to press pause in 3, 2, 1. As you can see, I cannot move. I am trying to move with the arrow keys and with the mouse. Nothing happens. And now when I press resume, we are going back to the game running state, and everything should be back to normal, back to execute. Okay, so everything is going back to normal. I am able to move, I am able to shoot, and the logic of the game controller and the enemies is being performed. Okay, so if I press pause again, okay, and now we are going to choose the reload game option. The reload game option, what would do is just to reload the whole game, so we will start totally fresh. Okay, so right here, okay, the enemies and the NPCs are on their initial positions, and we have just finished the lesson of the game controller. What we have done is we have used the knowledge we got from our finite state machine to create a finite state machine for the game controller to control all the elements of the game, to keep track of all the things that are going on when you are running a game. Okay, first of all, we started by doing the main menu state, where we were displaying a play button. Okay, from this state we transitioned to the game loading state, and from that state we were transitioning to the game running state. In the game running state, the logic of the elements was performed, and if we want in this state, we were transitioning to the win state. Okay, so that's for the lesson of today.